number 10 on factoring, that would be,
Okay.
because that's where I left off. We did all those in class that I did, so.
Okay.
Yeah.
Go to number 10. Hold on a moment. Let me get everything set here.
Yeah, no problem.
Number 10.
Yeah.
Wow, these look hard.
Do they look, yeah.
Well, anytime I see something to the fourth power, it looks hard.
Yeah.
However,
Mm-hmm.
let's break this thing down.
Okay.
In other words, we don't have to factor this based on the way it looks now.
Mm-hmm.
Can I take a greatest common factor out?
Yeah, we could do,
Always check for that first.
okay. I think, yeah, 5 would be the greatest common factor.
5 what? You can take
Five.
a variable out also.
We could
5,
do 5xy,
5y.
this y.
Well, do you see why? You can only do 5y. I have a y in every term.
Okay.
I do not have an x in every term.
No.
So you need something in every term. In other words, when you factor something out, it means when I divide that by 5y, I'm going to get an integer. And of course,
Okay.
I have to divide that by 5y and that by 5y. That's
Okay.
what factoring means, is
Right.
you're dividing every term by 5y. So what do you have left?
Okay, so it'd be, yeah, so it'd be 5y on the outside and then it'd be parentheses.
That equal to?
That'd just be equal to x, y?
Well, the y's cancel, the 5's cancel. What am I left with?
X to the fourth.
Now, before you go to the next term, make sure
Mm-hmm.
you multiply these two together and it's the same thing as that.
Okay.
Is it?
Yeah, 5y x to the fourth, or 5xy to
Yeah.
the fourth.
Well, I
Yeah.
didn't mean the whole thing. I meant the
Oh,
numerator.
okay.
Is
Oh,
the
yeah.
numerator 5y(x to the fourth)? And it is.
Uh-huh.
Okay. Now,
Okay.
what's the second term?
So the second term would be,
Do that division.
so it'd be 4xy, or 4x to the second.
And the third term.
And then it would be minus 2y.
Just 2.
Or minus 2 because we don't want the y, because it'd be y to the second.
Now, let me erase all the squares and circles that I've drawn
Okay.
so that you can verify that we factored it correctly.
Yeah.
Is when I multiply, and this is a very important step.
Mm-hmm.
You always want to be checking. A, B, C. Always be checking.
Okay.
Okay? So
Yeah.
let me take away the division because that's confusing the issue.
Mm-hmm.
Now, when you multiply that times that, do you get that?
We do, yeah.
Yeah, exactly.
Yeah.
And that's what you always want to be doing to make sure you
Okay.
factored it correctly.
Okay.
Okay? Now,
Cool.
the rest of it is a little complicated.
Mm-hmm.
We want to see if we can factor that.
Okay.
Okay, so let me write that all by itself. Oh my God, I cannot believe they did this to you.
That's crazy. Oh, yeah, we just took the math test yesterday. I thought I did really well on it, so that was good.
All right,
So,
I'm going to give you a different problem temporarily
okay.
before we do this problem.
Okay.
This problem is so hard,
Mm-hmm.
I want to make sure you can do an easier problem.
Sure.
Factor this for me. Hold on, let me think a second.
Sure.
Would you factor that?
Okay. Well, we would do, um,
Not
we
so,
could do,
not so easy, is it?
no.
Well, let me make it easier for you.
Okay.
I'm going to introduce you to something called U substitution.
Use substitution.
Uh-huh.
Okay.
It's a thing that is used in all higher math. It's very, very common when you get to calculus.
Okay.
Okay? What if I let U, and you always let U equal that term. In
Okay.
other words, what we have here is what I call a quadratic in disguise. This
Mm-hmm.
is, even though it looks like a quartic, because it's to the fourth power,
Mm-hmm.
it's really a quadratic, because this term here is the square of that term there. Whenever you have that, it's really a quadratic in disguise.
Okay.
Okay? And
Yeah.
the way to really solve quadratics in disguise, there's all kinds of them, is to use U substitution. And you let U equal to the middle term.
Okay.
So what would U squared be equal to?
U squared x to the
If
fourth.
U is equal to, yes, if U is equal to x squared, then U squared is equal to x to the fourth.
Okay.
Okay? So now I really have U squared plus U minus 2
Mm-hmm.
when I use U substitution. Well, this is not a quadratic in disguise. It's a normal looking quadratic.
Right.
How would you factor that?
Well, you just put U on the outside of the parentheses, and then it'd be plus 1 and then minus 2.
Yeah.
Okay.
Well, since U is equal to x squared, I'm going to make this x squared plus 1, and I'm going to
Mm-hmm.
make this x squared minus 2.
Right.
And notice that when I erase all this garbage here,
Mm-hmm.
if I multiply x squared plus 1 times x squared minus 2, I get that.
Okay.
In other words, I factored it. But I was
Mm-hmm.
only able to factor it because I recognized that it was a quadratic in disguise.
Okay.
Okay? So, and don't forget your 5y. Your 5y is still there.
Mm-hmm.
So this is the answer to the problem,
That makes sense.
how to factor
Okay.
it. Okay? Excuse me. I'm sorry. That's not the answer to your problem. I made one up.
Oh, yeah. No, no, no. I knew that.
Made it
Yeah.
simpler. And the reason I did
Mm-hmm.
is because if we look at the quadratic that you're looking at,
Mm-hmm.
it's a lot harder.
It is,
That
yeah.
doesn't factor.
Uh-oh.
I got to use the quadratic equation on this.
Right.
Well, I'm still going to use U substitution. So I'm
Mm-hmm.
still going to let U equal x squared. And I'm going to make U squared equal x to the fourth.
Mm-hmm.
So now I can write this U squared plus 4U minus 2, right?
Mm-hmm.
That does not factor very well.
No.
The only way that factors is using the quadratic formula.
Okay.
Well, u is equal to minus b plus or minus the square root of 4a, excuse me,
You're all right.
b squared minus 4ac, called the
Divided by 2a, right?
right.
Okay.
Okay. So
Okay.
if I want to factor this and I can't factor it using normal techniques, I have to use the quadratic formula. Every quadratic can be factored. It's just a question of whether you can do it easy or whether you can do it tough.
Okay.
And when you have to use the quadratic formula, that's doing it the hard way. Well, what is u equal to? What's minus b?
Would that be? I'm not sure what minus b would be. Would that?
Well, let's talk about that. What's
Okay.
a, b, and c equal to? Because we have an a, b, and a c there.
Right.
A equals the coefficient of the squared term, so that's 1. B equals the coefficient of the non-squared term, that's 4. And C equals the constant.
Which is why it's 2.
Okay? So, what's u equal to?
So u would have to be equal to.
Just substitute direct, and we'll solve it afterwards. Never try to solve these all in your head. The way to do these problems is just substitute. What's minus b? If b is 4, what's minus b?
Then it'd be minus 4.
Plus or minus the square root. What's b squared?
16. Minus 4 times minus 2.
Now, all over 2.
2.
All right?
Okay.
Let me erase some of this stuff.
Okay.
Now, it's this point here where most people make their mistakes. This is a complicated thing to figure out. One of the reasons everybody makes a mistake here is because I'm looking at a negative sign there and a negative sign there. But this negative sign means subtraction. That negative sign just means negative 2.
Okay.
So the way to always do these, to simplify them, is to do this part first. Well, what is 4 times 1 times negative 2?
Negative 8.
Okay, so I'm going to write negative 8 there.
Okay.
Now what is 16 minus a negative 8?
24. Minus 24.
No, plus 24.
Or no, yeah, plus 24.
Correct. So I'm going to make u now equal to minus 4 plus or minus the square root of 24 all over 2.
Okay.
Okay, now let's simplify that. What's the square root of 24 equal to?
The square root of 12. 2 root 12.
Well,
Or would it be?
you have to
12.
factor 24, and you have to have one of the factors be a perfect square. So what would that be? In other words, not just any 2 factors will do. 24 times 1 doesn't do. There's no perfect square there. 12 times 2 doesn't work. There's
no 4 and
square there.
Yeah.
How about 4 times 6?
Right. Yep.
Square root of 4 times square root of 6 means that square root of 24 is actually that.
Right. To simplify.
So now let's plug that in. So minus 4 plus or minus 2 root 6 all over 2. Now we have to simplify that. What can I do to simplify that?
You could divide minus 4 by 2.
Okay, so that's minus 2
plus or minus 2 to the root
2's
6.
cancel there, so I'm left with just that.
Cool.
That's my answer for u.
Okay.
Okay?
Okay.
Problem is that u is equal to x squared.
Mm-hmm.
So, if we're going to fill this back in, we have minus 2. Wow.
Mm-hmm.
All right, hold on a moment.
Okay.
These aren't easy, let me tell you.
No, they really aren't.
You can see.
Yeah. I don't get why he would just start us out, like, working up to this, not just, like, give this to us.
This is hard algebra. This is definitely algebra 2, maybe even algebra 3.
Yeah.
All right? So, let's go
Okay.
back to our original function. We have 5y times, well, u squared. U is 2 plus or minus 6, right?
Right.
So, negative 2, excuse me,
Mm-hmm.
plus or minus square root of 6. That's u. We're squaring it.
Okay.
Now, plus 4 times u. You with me?
Kind of, yeah. Yeah, I think I am.
I'm going to use brackets on the outside so that I can use parentheses on the inside.
Okay.
Okay? This is u.
Mm-hmm.
That's u. Well, it's u squared plus 4u minus 2.
Mm-hmm.
So u turns into this. And now I kind of have my answer. I mean, oh boy.
Mm-hmm.
I can't believe they gave you this problem.
This is insane,
Are you
man.
taking honors algebra 2?
No, just normal.
Normal algebra 2.
Mm-hmm.
All right. So this is my answer.
My friend in honors said they're not doing this yet, so I mean, it's like,
This is very, very difficult. And that's why
yeah.
I said, uh-oh, when I saw that, because that doesn't factor nicely.
No.
It
Really.
factors only using the quadratic formula,
Uh-huh.
and which merely makes the problem a lot more complicated.
Yeah.
If this was u squared plus u minus 2, then it would be relatively easy,
Mm-hmm.
because we'd be able to factor it using u substitution. But
Mm-hmm.
the fact that they made it a quadratic, even when I use u substitution, they made it a quadratic that couldn't be factored without using the quadratic formula,
Mm-hmm.
makes the problem just super tough.
Yeah.
Okay? Well, let's go back and look at the original problem. We had a quartic, right?
Mm-hmm.
X to the
Right. Yeah.
quartic. How many solutions should we have?
Well, shouldn't we have 4 solutions?
Yeah, we should.
Okay.
Now,
Yeah.
we don't necessarily have to have 4 different solutions, but we have to have 4 solutions.
Right.
So, if we solve this, I get 5y times, I'll keep using brackets, just, now this squared, wow, gives you 2 solutions.
Yeah.
4 plus 4 times root 6 plus 6, or 4 minus
4 root 6 plus 6.
the same. So both of those work. In other words, both of those satisfy that.
Mm-hmm.
And if I do the rest of it, I get minus 8 plus 4 root 6 and minus 8 minus 4 root 6 minus 2.
Wow.
I know. This is stupid.
Yeah, this is
It's
insane.
stupid. It's insane in that your teacher's trying to teach you anything by this problem.
Uh-huh.
It would be the equivalent if I wanted to teach you how to ski to drop you on a double black course.
Right.
That'd be a horrible way to teach you how to ski. The best way to
They're starting out.
teach you how to ski
Yeah.
is to start them on the green slopes, and then the medium slopes, then the hard slopes. And then maybe eventually, if you get good enough, you can do black slopes.
Right. Or teaching a 4-year-old how to play baseball in the MLB. You know, I mean, like.
Exactly. You don't start with the hardest frickin' problem you can even imagine. And
You really don't.
that's what they've done here.
Yeah.
Now, you will notice that I am going to end up with 4 solutions.
Yeah.
Because 5y times that's one solution. 5y times that is another solution. And then that's a third solution, and that's a fourth solution.
Okay.
And they're all numbers. There's nothing here that's not a number. You don't see any variables here.
No.
Okay? Excuse me. There is a variable, y. Everything else is numbers. So you're going to end up with 4 answers that are all have a y in them.
Okay.
And I could write them all out, but it would take the next 6 minutes, and I can't believe that's the best use of our time.
Right.
Wow. So give me another problem. Let's spend the next 5 minutes on a useful problem.
Sure.
If it's hard, I mean, let's give it a shot. Unfortunately, I can't go late tonight, Dylan. I have an 8 o'clock.
Yeah.
So I'm going to have to run at 8, but we still have 5 minutes.
No worries, yeah. We could do number 11, so it's x squared plus 7x plus 12.
Oh, this is more of a green slope problem.
Yeah, this one's pretty simple.
Factor that for me.
Sure, so it would be x plus 4, then x plus 3.
What's next?
Let's do, we could do 2x to the third minus 200x.
What's the greatest common factor? Always look to that first.
Yeah, 2. Actually, no.
2 what? You always leave the variable out. Whenever I ask you about greatest common factor, you find a number, but the greatest common factor is actually 2x.
Right.
In other words, I can divide both terms by 2x and get an integer.
Okay.
Okay? Well, what's left over?
And then we would do parentheses.
Goes here.
We could do, I'm trying to think.
You can only do one thing. You got no choices. What's 2x cubed divided by 2x?
2x to the second.
No, the 2's cancel.
Yeah, it says it'd be just x to the, just x. Yeah.
X squared.
To the second.
Now, multiply those 2 back together again. Do you get that?
Yep.
That's what you always want to be doing. Never go to the next step until you've done that step.
Okay. And then it'd be minus 100.
Well, it just saves on mistakes. Yeah, exactly.
Yeah.
Minus 100. And now multiply 2x times 100, and you get that.
Okay.
So now we know we've done it correctly. Okay? However, we're not quite done. X squared minus 100. What does that look like? What kind of a factoring problem is that?
We could do
Difference of what? What's that called?
difference of
Perfect
common factors. No, perfect squares.
Perfect squares. Difference of perfect squares. Why is it called that? That's a perfect square. That's a perfect square. And
Right.
we're subtracting them. So it's the difference of perfect squares. How does that factor?
We could do x minus 50 and then x plus 50.
No, it's always factored like this.
Yeah, my bad. Yeah, that's what I meant. I was like,
whenever you have difference of perfect squares, okay, this is the difference of perfect squares. It's always a minus b times a plus b.
Okay.
Well, in this case, a is x and b is 10. Right? In other words, b is the square root of the second term. The square root of 100 is 10.
Right.
So it's x minus 10 times x plus 10.
Okay.
Okay? And that's your final answer. You have factored it. Whenever you factor it and you have nothing but linear terms left, you have factored it all the way down. Now, last question. If I set that equal to 0, tell me what my solutions are.
X minus 10 is equal to 0, then x plus 10 is equal to 0.
My solutions for x.
So x would be equal to minus 5, and then x would be equal to plus 5.
No. X is
right.
10 for that one.
And then minus 10.
And minus 10 for that one. But you're forgetting the one that everybody forgets.
The 2x.
No, yeah. So when 2x is equal to 0, what does x have to be?
0.
There's 3 solutions.
Cool.
And that's how many we would expect. Remember, we started out with a cubic.
Right.
When you start out with a cubic, you expect there to be 3 solutions. Now, occasionally you'll have functions where 2 of the solutions will be the same. It won't look like 3 unique solutions, but that's okay. The fact is that you always have 3 solutions here, even if the multiplicity factor is, more than 1. But it's important to know that you should expect 3 solutions, because that way you won't make that mistake. Everybody makes this mistake. They don't set that equal to 0.
Yeah.
In other words, the first answer you gave would be what 90% of the students are going to put on their test, and it's wrong. And you could spot that mistake by noticing that, there's only 2 solutions. There's got to be a third solution somewhere.
Okay.
Yeah.
Cool.
All right, Dylan, I got to run.
Sounds good.
Talk to you next time.
All right.